Yo, what is up? Fatboy G's here with another MassTransit live coding video. Okay, that was for my 13-year-old. She says my intros are really boring, so I had to kind of spice it up again. I don't know if that worked or not, but that's how it works. So, hey, good evening. I wanted to spend a little time tonight and talk about middleware. This is a question that comes around a lot. A lot of people ask on the forums. They're like, well, forums, whatever they are, on the Discord server or even on Stack Overflow, that one of the common questions is, how do I build middleware? How do I sort of filter, to process a message, or how do I put a filter in to do authentication, or I want to validate the message before my consumer gets it. So kind of wanted to look at some of these capabilities and how MassTransit is composed, kind of walk you through that, and then go through building a filter. We're going to add it to one of the lighter weight samples that we have, the Trashlantis sample. We'll just create a filter in there that'll just kind of do some basic stuff for us, just to kind of show how it works. So without anything else, let's get started. So I have the Trashlantis sample already open. And if you remember, this is the app from last time where we have a simple UI where we want to tell it to take out the trash. We send a message to say take out the trash, we give it a bin number, and then off in the background our service runs a saga. We used this to demonstrate the in-memory outbox last time, but this time we're just going to use it because it already has a consumer set up and it's easy enough to work with, so we're going to start there. So MassTransit is built around a series of pipes and filters to compose kind of the internal message routing of MassTransit. So much so that I actually extracted this out to another library called...
I found this on developers, pipes and filters to compose time.
I don't know why that came on. Yeah, she's annoying sometimes. That ALEXA person. Anyway, yeah, that caught me off guard. So I had extracted this into a project called Green Pipes, which if you see the Green Pipes namespace around MassTransit, just know that that's kind of where all the pipes and filters functionality is based. So to that end, within the docs, there's a page on the receive pipeline where you can see that the actual receive pipeline, this kind of shows all of the different filters that compose the pipeline and the different contexts that are passed on those filters. I think I can zoom in on this. Hopefully it'll maintain some fidelity. So at the beginning of a receive, when a transport messages comes in, or when you call send on a mediator, it actually creates a receive context. The receive context, it implements pipe context, which has a series of payloads for keeping track of basically baggage that goes along with the context. And it first sends that through a series of filters. The first filter it hits is the dead letter filter, which the way the filters work is each filter in the pipeline has a simple atom that it gets sent with. And let me see if I can find that real quick. You gotta find it, symbols, types. It's like, hey, that's somewhere else. All the places. If we go to, well, let's just start to create one so that we have it. And then we'll be able to see what that is, just so we can have that for reference. No, I don't. Okay, so we're gonna just create a filter just so we can see what the interface type looks like, because I don't want to go find it. And then we'll just use ReSharper Writer to go in and look at it. And so we can see from a filter, I'll my font up here. The filter has a single method where it takes a context. So in this case, the context would be consume context or whatever we have. And it has one method, it's called send. So for a filter, send is called, it's passed the context, and it's also passed the pipe, which is the next part of the overall pipeline structure. So filter takes two arguments, context and pipe, whereas pipe has the same send method with one argument. So pipe is like it's the shortened version. It doesn't need to know next, because when you send to a pipe, you're not expecting to do anything beyond what the pipe knows about. Whereas the filter, you're expected to do your work and call next. So when we look back at the receive pipeline, when dead letter is called, the dead letter filter runs, all it does is immediately call next dot send. So it sends it to the next pipeline component, which in this case is the rescue filter. And the reason it does that is because dead letter only comes into effect at the end of the pipeline execution. So dead letter is going to maintain the call stack scope and basically be in scope for the execution of that context through the pipeline. But it doesn't matter until the end, when it checks to see if someone consumed it, and if it wasn't consumed, moves it to the skipped queue. So the next one that comes in is rescue. Rescue comes in and says, okay, well, again, I don't do anything up front, but if an exception is thrown and it makes it to me, I'm going to branch off to another pipe, which is the rescue pipe, which is where faults are generated and errors are published, and it's moved to the error queue. The very next pipe or the next filter that's hit in the receive pipe is the deserializer. And this is where it looks at the receive context, looks at the content type, and then identifies which deserializer to use for the message. So if it looks at it and it says, oh, this is JSON, I'm going to use the JSON deserializer, it then passes it to that deserializer, which creates the consume context. So the consume context is what you get delivered with every message that comes in from MassTransit. And this is the deserialized message body. It has all the headers, things like that. Now we can put filters in that, such as like a retry filter or anything like that, on just that consume context type, and we can discuss that. The next filter that comes in before we get down to a consume context of T is the message type filter. So what this will do is it will look at the message type, and it will look at the message body or the message envelope and say, okay, I have a consumer of this type. Does this message support that type? And if that message supports that type, it will then go through this pipe. Otherwise, it will just continue and go through, and any of the other types will check to see, and it will only dispatch the consume context of T to those pipes if that message supports those message types. So that's where if the message type isn't supported or isn't in the envelope, it won't ever even go down that path of the pipeline. And there's a branch of the pipe for every message type that is consumed by consumers, sagas, routing slip, whatever. Once you have the consume context of T, which has the message property on it, you can insert filters in that as well. So you can get filters very specific to the message type of T. And the reason this is useful is because MassTransit is very type-based. Everything is about having that generic type T. I don't like to pass object around because object is noisy. You don't know what it is. You don't know what to do with it. The discoverability is horrible. So I never cast anything down to object. I always keep it as the generic type all the way through the pipeline. And the benefit of that is you can actually use that type to resolve other services, to know the properties and not have to do weird reflection type stuff. It's just super valuable to keep T around, and the entire pipeline has been built around that concept of keeping the actual types live versus putting them down in object and having them disappear. So you can create filters on consume context. You can also still add filters for types that are supported by consume context of T. So for instance, if I wanted to add a filter after the message type, but don't care about the message type, I could create a filter on consume context and add it in there. And what MassTransit will do when it builds the filter pipeline is it will actually split off that subtype, call your filter, and then merge them back together and rejoin the pipeline. So the pipeline is always going further down the pipe. It's never branching off, coming back, and then going forward. And the reason for that is if this filter added payload or properties or modified the consume context in some way, that needs to be persisted for the next filter in the pipeline. So we still have consume context of T. Now we actually hit a consumer factory. So the consumer factory isn't a filter, but it's a special type of pipe where you send it the consume context and it will go off And depending upon whether you're using a dependency injection container or whether you're using factory methods, things like that, it will go off and create the consumer and create a new type of consume context, which has two generic arguments, the type of the consumer and the message type. So now I have a consumer, I have a message, and those two things are available and are now passed down the pipeline as a, I guess, kind of a formalized tuple, so to speak, in that it's the consumer consume context. It has both of those things with it, but also still carries the consume context with it. And if you're using a dependency injection container, it's at this point that there is a container lifecycle created. So it'll create a scope for the receipt of that message at the point of the consumer factory. It works very similar for the Saga repository. When it actually goes off and loads a Saga, it will create a Saga consume context that will have both the Saga instance and the message as well. But I just don't have that drawn out here in the filter pipe. You can add filters here as well. You can add them for consumer consume context. You can add them for consumer consume context just with the consumer. Any of those types are on there. You can add them for consume context of T. Any types that are supported can be added, and they're always kept in order as you add them when configuring the pipeline. So order matters. If you just throw a bunch of stuff to say, oh, use this, use this, use this, and you don't put them in order, they won't behave as you expect because order matters in the pipeline. So if your middleware needs to run before retry middleware or after retry middleware, that's what you need to make sure you configure your pipeline that way. So once all those filters have run, it actually calls the consume method on the consumer. That actually calls some observers, which aren't filters, but they're called when messages are consumed. And there's a big difference between a filter and an observer. A filter is meant to do things to the message, such as handle exceptions or modify message contents or add payloads or validate data or retry on faults, or really you can do anything with them. Consumers are really just meant to know that something happened. You aren't really supposed to modify the message in a consumer, but the fact that I call pre-consume, I mean, I've seen people do it. It isn't illegal. I mean, the framework is pretty flexible. It's running with sharp scissors. You can do what you want, but you might cut your finger off. So definitely keep that in mind. Consumer observers, very different than filters, and consume filters don't have scope. So consumers are called in return. The observers are called in return, whereas the filters continue to pass down. So hopefully that gives kind of a good intro to kind of the receive pipeline, how it's structured. And the send pipelines are very similar. They all kind of work, in a very similar way. So that's that. That's on the website. It's in the documentation to receive pipeline. So yeah, you can see that there. Yeah, so now I want to go back to our project because I want us to actually create a filter that's going to handle the message of receiving the trash bin message that we're sending out. So I'm going to bring this up, and we had started to create a filter. We're going to start with a very simple filter that just gets plugged into the consume context and just writes something out. I mean, that's about as simple as you can get, is just writing something to the console. So we have to create two methods when we create a filter, and let's just call this the console consume filter. I don't know, whatever. We're actually going to move this to a directory. We're just going to call this filter pipeline or something. I don't know. I think it'll let me do that. Nope, it's not going to create it for me. Oh well, we're not going to worry about it. There's two methods I have to implement when I create a filter. The first one is probe, and probe is used to provide some discoverability to the pipeline. When a pipeline is constructed, you can call bus.getProbeResult, and it will return you an object graph of everything it found in the pipeline. And then there's a helper method, I think in the test framework or somewhere called toJSONResult, where you can actually just write it out as JSON and see the entire pipeline after it's composed on the bus. So it's really helpful to kind of visualize what's been created and to kind of troubleshoot where your filter ended up, and also to just make sure it's being added. So I'm going to do context.createFilterScope, and I'm just going to call it consume filter. And this is just, well, that would probably be not, this will be my console consume filter, because there actually is a consume filter. It's what calls the consumers. And I could add anything I want to here. I could add a key value pair that says, you know, output, you know, console, whatever. You know, it doesn't matter. It's just a tree of dictionary nodes. So there isn't any structure to it. It just ends up being what's compatible with the JSON document. And then I have my send method. The two things that I have to call, the only thing I actually have to call, and I could just flat out return next.send context. I could literally do that. My filter doesn't do anything at this point, but it's playing nice and it's calling next. If you don't call next, you will kill the pipeline. And I can show that here too, is I can set this to nothing and it will move it to the skipped filter or it'll move it to the skipped queue because you didn't consume anything. You never made it down the pipeline. It's a good way to shut off all filtering, all message processing. But I mean, that's the power that the filters have, is you could literally filter with a filter. You could say, oh, well, this message came from this endpoint. I don't trust it, so I'm gonna junk it. I'm gonna throw an error. I'm just gonna discard it silently. I mean, you have full control over the message. So it literally lets you do everything. And the reason you have full control is because MassTransit is built around this tile architecture. So it needs full control to do everything it does. Thus the whole point of having that. But I want to do something. I want to do something fun. I'm just going to do console.writeLine because why not? And I'm going to say, we'll just call it consume, and we'll write something out, something from the context. Let's write out the, let's just write out the message ID because that's about all I know at this point. And then I'm going to call next. Now I could do this two different ways, and this is a question that comes up a lot, and the people who wrote the .NET framework have their opinion and I have mine. You could do it this way and create your method as async and call next.send, and this will actually create a call state machine for running the async await functionality. And that's great. And you have to do that for a lot of cases, especially if you're going to do try catch, if you're going to have using, anything that creates scope or puts something in that you need to keep track of. Or if you're going to do any processing or cleanup or anything after calling next.send. But in this case, I'm doing nothing, so I'm just going to return. We'll probably come back to this and regret it, but for now it's going to be fine. Now I want to go to my trash consumer because I think that's the one that I'm going to put this filter in front of. Trash consumer takes the empty trash bin message. And for now, I'm just going to go look and see where that's registered. It's registered right here, but I don't have a, doesn't look like I have a definition for it. So maybe I could put it in front of the saga. Nah, I don't want to mess with the saga. We're going to put it in front of the consumer. So we're going to create a definition for the consumer. So because we're using the automatic configure endpoints of AdBus, we're going to use a definition for the class that consumes trash consumer. So we're going to create a trash consumer definition. And that is a consumer definition of trash consumer. And we are going to override the configure consumer method. The configure consumer method gives us the ability to configure the actual consumer or the receive endpoint that the consumer is being registered on. And I'm going to show the difference here when we look at this. So the first thing I'm going to do is I'm just going to say endpoint configurator.use filter, and I'm going to create my console consume filter. And that's the only thing I'm going to add at this point, and we'll see why that matters. I'm going to go back to my add consumer and add my type of trash consumer definition. And I'm going to go back out. I'm going to rerun my service. So with the service coming up, it's going to compile, then it's going to run. I think it's going to compile, and then it's going to run. Oh, my console was stuck. Awesome. So we're up and running. I'm going to go back to the browser. I'm going to go back to Swagger UI. I'm going to take us back down to 66. And I'm going to go look out here. I'm going to see that the saga ran. We're going to see that it declared the exchange name empty trash bin. Even before it logged that it called send, I had already written out the consume where I write the message ID, and that's the message ID that was run. If I look at the send here, I can see that the message ID that my filter wrote out actually matches the message ID of the send and matches the message ID of the receive for the empty trash bin and the consumer that actually consumed it. So that ran my filter. So jump back to that. Within the consumer definition, which configures the receive endpoint, all I did was say use filter, and I have my console consume filter, and now that's being run. Awesome. That's a filter. It's pretty simple to create one. I know that that seems simple, but that was super simple. Let's create another. Let's create another filter just for fun, and we're going to call this the console consume with consumer filter. How does that sound for fun? And we're going to leave it as consume context for now. And we're going to say consume with consumer, and we're going to output the same message ID. Don't really think that there's too much else to put there. And the reason I'm outputting a different message ID is because I want to show how putting the filter in different places makes a difference. So I'm going to kill this. I'm going to go back here. I'm going to go to where I configure this. And here I'm going to say consumer configurator dot use filter, and I'm going to pass the consume with consumer filter. Now, as you can see, I'm getting an error. And the reason is because the consumer configurator is a pipe configurator of consumer consume context T consumer. So I can't add consume context to this. Now, I could do it if I knew the message type. I could go to a consume message configurator, which has, a similar approach, but I can't add just a consume context. And the reason for that is I know the consumer type. I'm in my consumer definition. I should be adding a filter specific to that consumer type. So let's go change this and say this is a consumer consume context of T consumer. The configurator rater, yeah. Yes, there's a lot of configurators. That's what they should just call writer, the configurator rater. So I'm going to add the generic type to this. And now you can see I have to implement a different method. So I'm going to come down here, and I think if I do, I thought it would let me do a real easy implement other method instead, but we'll just go with what we have here. So I've changed my pipe definition so that I take the consumer consume context, which has the consumer on it. Yeah, so that should work now. So let's go back. It should clean up the error. I do have to pass the generic type. And now if I go out and run this, we're up and running. We go back to the website. We'll just go down another number. And we'll see that we have two messages in here. Let me see if I can. We have two messages in here. The first one is consume, and that came from our first filter. And then we have our consume with consumer, same message ID, but that filter is being called later on. And at that point, the consumer exists. So that's how different pieces of middleware can fit in different parts of the pipeline. We'll go ahead and kill that. So two different examples of middleware filters that do their thing. Now let's be annoying. Let's just comment this out and just return task.completed task. So we're gonna break the pipeline on purpose. We're gonna come out here. We're gonna run. It's up and running. We're going to go back to the website. We're going to hit up 64. And what are we going to have happen? Okay. So we didn't call our second filter. We did call the first one because we wrote out consume. But then the very next thing we see is a skip for that message ID. And the reason we skipped it is because that message was not consumed. There was no notification back to the transport that the message was consumed. So therefore it said, oh, well, I'm going to move it to the skip queue because it's dead lettered. No, no one said they consumed it, so it's gone. And the reason we do this is because people screw up. They don't have the right message types or whatever, and we don't want to lose messages. So we would rather move it to the skipped queue. You can look at it, triage those on your own, do whatever you want, so on and so forth. So that's what happens if we just completely drop dead. Now, if I had said something like context.notify consumed, which I can't entirely do on here because I don't actually have a consume context of T because it never made it to a message type, which is protecting us from ourselves. But if I leap around the corner and call notify consumed, oh, I still can't do it. Good. I wasn't completely dumb. Okay, so that's preventing me from doing that. But if I had called notified consumed with that information, it would actually log that as consumed so that the dead letter filter would not come into play. If I had called notified faulted, it would force it to fault. Never call those yourself. I'm serious. They're internal to MassTransit. I think they even say on them, don't call these things. But you've been warned. Not meant for, unless you're writing your own consumers and building your own entire pipeline to dispatch messages, don't call those methods. I didn't want to hide them because I need them and I don't like doing like sneaky tricks like casting stuff for them to work. So I'm going to put this back in play because we want that to work. So we'll put that back in. We're going to call next. We're going to play nice. There's one more type that I can put in here for a consumer, and that's one that actually has a message. So I'm going to put the T message in here. And T message has to be a class. And once again, I'm going to change my method. So now it's with consumer/message. I'm going to route the message ID. Great. I could actually probably even do something with the message. Like maybe put the message type. Yeah, that would be fun. Let's do that. Well, let's do message type. And now let's go add that filter in our consumer definition, which is still in this class. So we added a filter there. We now want to add our message filter, which I don't even remember what I called it, but I think I just added another generic type to it. What's the message I do? Empty trash bin? So that's the message filter type. But again, I'm going to get an error because I need to tell it what message I'm going to do this on. So I need to say .message empty trash bin and then add it within that type. Maybe. Oh, sorry. There's two different overloads here. One is consumer message because I want the consumer and the message. If I just wanted the message, I would use .message and it wouldn't have the consumer argument on there. Yeah. So now I have three filters. Consume with consumer message, consumer message, and all those. We'll go out here and we'll run those. Once they get up and running. This has a saga with Entity Framework, so it takes it a second to wake up. We'll go back to our website. We'll go to 63. Come out here, we'll see that saga run, and then we'll see the message come out, and we should see 3 messages. We should see consume, we should see consume with consumer, and we should see consume with consumer message type, which we did. Awesome, great. So all 3 of our filters are being run, doing their thing. Awesomeness. So that's how you can just create filters. It's great if you know the consumer types, if you know the message types, you know all that stuff that's going to go on. Where it becomes challenging, though, is sometimes you want to have generic filters that can be applied to any consumer or any message type. And this is where we've got to do a little work on the setup. So previously with the definition, I was calling use consumer or use filter because I knew the filter type and I knew to call it within here and I knew to call it within there and everything was great. But I can't do that here. So to one of the, again, because I don't like to go to object and I don't want to like say, oh, well, if consume context has this and has that. So to configure your filters, once you've created them, you can create a configuration observer that can be used to go out and add your filter to the pipe with the specified types. So I'm going to do the first one. Hey, Brave Cobra 2, welcome. I think all the cool streamers say something else too, but I don't really have that. So it's like, hey, welcome, glad to have you. Seriously, my 13-year-old is convinced I have to up my game here. So, yeah, I'm working on it. I'm working on it. At least I got almost the front-facing camera now, even if it is my phone. So to get this filter to be able to apply it to anything, like I want to be able to take this filter here, and I want to have one to consume context for message types. So this is going to be my console consume message filter. And it's a message filter of tMessage. And it's going to be able to apply to any consume context of tMessage. So we'll change this here. And we'll output the message type just for fun. Thanks, I'm doing great. Awesome. Type metadata cache tmessage.shortname, and we'll spit this out because we want to consume the message. We want to know the type. We know the message ID, but we need to be able to add this. And if we don't know the message type, it makes it kind of hard to add. Now we could, if we knew it in advance, we could just go to the receive endpoint configurator and say endpoint configurator.useFilter and say new message, what is it, consume of empty trash bin. What did I call it? Console consume message filter. But then I'm going to have to actually I think I have to tell it the message type. No, I think I have to do endpoint configurator.message. Yeah, see, I think it gets nasty. There's just no real easy way to do it. So what I can do is I can actually create a configuration observer. And I do that by saying, I'm going to have my console consume message filter configuration observer, because I had to put the word configuration in there somewhere. And I'm going to create a configuration observer. And if I'm lucky, I will figure out how to do this correctly. I think I have to override one method. Oh, it's more than one method. Execute activity, activity figured, compensate activity. Why do I feel like I'm missing some methods here? Okay, so that's for an execute activity. Huh. I feel like something is missing. And I don't know why. Let's go take a look at it. Oh, right. Yeah, we're gonna create our own. We're gonna cut back from that a second. So we're gonna create our consumer configuration observer, and we're gonna implement these types ourselves. And what this is going to do is there's two methods, and these are called, so every time you configure something in MassTransit, whether you're adding it to the pipeline and trying to get it sorted, the observers can be connected to be notified when certain things are done. So what I want to know is whenever a consumer is configured, I want to know the message type. That's all I want to know. So when consumer configured is called, I get that consumer configurator. And when a consumer's message is configured, I get the consumer message configurator. And they're all called configurators, of course. Now the consume pipe configurator, that's the receive endpoint configurator. That's what's going to be receiving the messages. The consumer message configurator or consumer configurator will configure those portions of the receive pipeline that are very specific to that consumer. So the consumer configurator starts all the way down here at the initial consume context. The consumer configurator, the consume configurator starts here. The consumer configurator starts here with the actual consumer within the consumer factory. And the reason that's important is because remember, the container lifecycle doesn't start until the consumer exists. So if I go back to the observer, I want to add a filter for my message type, and I don't need the container, so I'm just going to add it to the message pipe, the consume pipe configurator. So whenever a consumer message is configured, I'm going to say configurator.useFilter, and I'm going to say new consumer console consume message filter t message. Yes, it feels like an abstract consumer configurator filter service factory. Yes, it's inches away from being Java at this point. There's so many different things that can be configured. So many so that I can't even remember them all. Now I'm gonna try to figure this out. That's why I should practice. Because it has consumer and it has that and it has, I have a pipe configurator of T, which I have a consume context of T, which, because this consumes consume context of T message. And I want to do that within my configurator. I don't need the consumer, but I want to do it within the consume message. So what am I missing here? Configurator dot add pipe specification, consume context of T. It's there. New filter pipe specification, consume context of T, message. New console, consume message filter, T message. Okay, I think that's what I had to do. Okay. So I had to create a filter pipe specification because I don't have a use filter overload that. Which basically just tells it the type, and then when the pipeline is built, it calls add filter passing my filter. I want to say there's probably something that calls this, but I don't know what it is. Let's see if we can find a cleaner way to do this. Use filter, consume context of T message. Let's see what happens if I pass one of these. Yeah, it doesn't like that. So you have to have a specification that does it. And that the filter pipe specification is the default one. You can pass it any type and it will add it properly. So now I'm going to add that to the pipeline. And if I remember right, we're outputting, what's our console output? Consume message. Right. Yeah. So we want to make sure that we can identify it. Consume with consumer, consume with that. So we have our configuration observer. Now let's go back to our trash consumer. And we're going to say endpoint configurator dot connect consumer configuration observer new. What do we call it? The consume message filter specification? No. I could remember from one screen to another what I called something. Console consume message configuration observer. And we're going to pass it the endpoint configurator. And we're going to make it public. Okay, so we've connected our observer that we created that's going to add the consume context of T filters to the receive endpoint. And we're doing it there because these are going to actually come in before the second two filters that we've configured here, because these need a consumer and this doesn't. So what we're going to actually see is that this one goes first, then this one, then this one, then this one. So when we run that, now we'll go send ourselves a message, and 62. And there you can see, I'll go over them in a second. So we see we actually get 4 different little pieces of output here. We get a consume message of empty trash bin. Then we get a consume of the consume context. That's interesting. Then we get the consume with consumer, and then we get the consume with consumer message. So let's look at what this looks like. So one of the questions in the chat was like, okay, you got 4 lines of code and I got no idea what it does. So what do we got here? So this is the definition for our consumer. It's called when we want to register the consumer on a receive endpoint. The first line connects an observer to the configuration so that when a consumer is configured, it configures the pipeline. The second one adds a filter to the consume context of the inbound receive pipeline. This one adds a filter to the consumer consume context part of the receive pipeline. And this one adds one to the consumer message type part of the pipeline. And what I'm going to do is I'm going to modify the bus startup here within program CS to once I'm doing run console, so I need my hosted service. Let's go to my MassTransit console hosted service. And let's say before we start up the bus, we're going to say output equals bus dot get probe result, which is going to run all those probes on the bus. And then we're going to call to JSON string, maybe? Maybe not. Where is that at? Get. I thought there was a. Maybe I don't have that. That might be annoying because I don't think I have that. I don't think I have the get JSON. Shoot, I don't know how I'm going to print that out because I don't have the JSON. I think that's only in the test framework. But I can set a breakpoint here and we can look at it. That would be awesome. Maybe. So let's run this now and see what that looks like. Is it in the test fixture? I'm going to just pull in one more NuGet package. Give me a pre-release package. I am running on the latest develop, by the way. So, oh no. Okay, we're back. I guess we had a little glitch with Twitch, so we're back to streaming now. It did a little reset, so welcome to the new world of crazy internet. So I'm pulling in this test package because I think my probe result is there. I'm really just looking for the get to JSON string. Yeah, so within the test framework, there's a to JSON string. I wouldn't normally pull in the test framework to a production service, but I wanted to be able to show this without going too crazy. So let's do a .NET run. So when we bring this up, we're going to see a complete dump of what the bus looks like before it even starts it. And there it is. Okay, so with that started up, I'm going to kind of scroll up to the top here. So what did those configuration methods do? So the output of a bus configuration is what you get when you use the probe. And we can see we have a bus, it has an address, we're using RabbitMQ, I have all the configuration ports, there's my password. I have a receive endpoint. This one is named Trash. It has an exchange name, exchange arguments, it's durable, all that great stuff. It has a topology with the different exchanges. And now it has filters. So at the filters section of a receive endpoint, you get all the detail. In this case, there's that dead letter filter, which is the first one, which if we go back to here, we can see that dead letter is the first filter in the pipe. So we have our dead letter filter. We have our rescue filter, which calls generate fault and move fault, which moves the error to the error queuer after producing a receive fault error. We have our deserialize filter, which is going to deserialize the message and create that consume context, which then sends to the consume pipe. For the filters, we have the dispatch pipe, which remember, we don't have any filters right here, but we do have filters here. And the reason we have filters here is because this message type filter is what we're seeing with this dispatch pipe. It's doing the conversion to consume context of empty trash bin. It then has its own output pipe that has its filters on it. The first one we can see is the console consume filter. And apparently I didn't rename one of these because it has the same name as the other. We then split, because remember, since we're now to the point of consume context of T, if we want to get just consume context, we split and we go out here and then we go back. So it creates that split, which calls that console consume filter non-generic version, has that output flag of console. And then we're back to this one. We then have our consumer, which calls the consumer factory. The consumer factory is going to create, the provider is dependency injection, so it's using MSDI. It's going to resolve that consumer, create that consumer consume context. It's then going to call some additional filters because we added two filters, one with the console consumer. So we had to split because we were only using part of the output. And then we go back to the other filter type, which has the consumer and the everything. So it's that whole complete filter. Finally, we get to where we actually call the consume method of consume context on the actual consumer class itself. So that's what the pipe looks like for that entire consumer. It's a lot of different filters. All of them we've added as part of those different, one through the observer and 3 of them directly. Yeah, so that's what a pipeline looks like, and it matches what you see in that diagram. This is the Saga one. You can see that it, this is the Saga endpoint. You can see that it actually deserializes, and its dispatch has its output type. It has its retry filter. So the retry filter there is doing a policy. It has 4, it has those intervals. All of that stuff is visible within this data. So that's my retry filter. This is my in-memory outbox filter. A couple other filters I have, the correlation ID filter, the one that goes out and queries the Saga for the property instance.bin number. So that's what it's using to correlate on. It'll output that query. I mean, there's a lot of detailed information in here, but it really gives you an idea of exactly what's happening within the pipeline. Then it goes out and loads the state machine, the instance type, current state property. All of that stuff is there. I mean, you even see like a complete breakdown of all the behaviors within the state machine. So during the initial state, when trash removal is requested with this data type, the behavior is a then, a publish, a transition to state. Because this is built on green pipes, Automatonymous is also built on green pipes, so it has all of the same discovery for get probe results. So you get all of that rich detail in terms of the state machine and how it's built. See here in the chat, thanks for the SNS fix. We got it running in production now. Awesome. There's some cool new stuff coming for Amazon SQS SNS that should make it a lot faster too. So hopefully that'll help out. We're going to add some stuff that I might live code after this just as a watch me work on MassTransit Twitch only kind of thing, just because why not, assuming Twitch can stay connected in the height of all this stuff. But we're going to look at using system threading.channels to add some buffering and kind of a prefetch concurrency kind of thing for SQS because of the way it works. Anyway, but anyway, cool. Glad that worked for you. And then, yeah, so that's it. That's kind of how all that stuff works. Here's an empty pipe. That's our bus pipeline. We don't use it for anything currently. So having that visibility is really great. We can see how that all works. We went through kind of how to create an observer, how we connect the different filters. And I could take any one of these off and it would, eliminate some of the noise. I do think I need to add a name to one of them because it was in the probe, it was using the same name. So this is T-message. We'll just call it that one. That way we can differentiate it. We'll just call this one with T-message also. So there we can see all those different filters running. The one other thing that I wanted to cover, I know we're coming up on an hour here, this ended up being way longer than I thought, is I want to cover the use of container scope, because that's one of the questions that commonly come up, is how do I access my container when I'm running a middleware filter. It isn't obvious, but it's kind of one of the nice benefits of working with the pipeline is the ability to access payloads. So I'm just going to stop this because we don't need to see that right now. So I'm going to go into the consume with consumer filter, and I'm going to, because I have the consumer, I have my consumer class there, and I'm sorry if I'm waving my fingers. I got to get a stand for my phone since I'm using it as a camera now, since you can't buy a webcam on the planet because everybody had to buy them for Zoom for the stay-at-home world that we're in now. Yeah, so I have to be post-consumer to be able to get this, and I know I'm using MSDI, so what I'm going to do is I'm going to say service provider equals context.getPayload service provider. And so within a consume context, any pipe context throughout the entire code base of green pipes, autonomous MassTransit has payloads. Payloads can be added at any point in the pipeline, and scopes can be created as well. There's proxies for pipelines, there's scopes for pipelines. So you could say, okay, I want all the payloads up to now, but I'm going to add some payloads, but I want those to go away when I exit. So you have all of the scoping capabilities, and it makes it pretty easy to kind of store data out of band, but with the actual context that's being passed around. Yes, because everything's called a filter. It's hard to differentiate where each belongs. Well, that's the thing is, it's all composed of filters. Filters are used everywhere. And if I had created a bunch of interfaces like receive filter, consume filter, saga filter, I probably would have just pulled my hair out duplicating interfaces. But yeah, it does get confusing, and that's why the visualization tools are kind of useful to dump that out and see what comes out. So I want to get my container and say I want to resolve something. I don't know what it is. Let's make it more interesting. Let's actually go down and do it here where we have the actual message type as well. So I want to ask for the service provider, and in this case, let's create another interface here. Let's call this an imessage validator with T-message. And what we want to be able to do is to get a validator from the container, and if we have one, validate the message. So we are going to call service provider.getService. We are going to missing a NuGet package reference. Installed packages. Microsoft extensions, dependency injection. Oh, so I only added those to the service originally. Go ahead and add those to components as well, just so I have access to the DI container. So when I'm creating this, I can put those in there. Gonna get mad at me in a second because I downgraded the package. I'm on the same version, preferably with the not double quoted. Okay. Okay, so I added MSDI on here. So now when I go to get service if we get rid of this, we should get the actual service provider that lets me do real work. I'm going to get the imessage validator of tMessage. Where is it pulling that from? There it is. Okay, now we got it. We got get service with message validator. If validator is not equal to null, we are going to call await validator dot validate message. And we will pass it context dot message. In this case, we'll add a method to it for validate. Need a generic type. We already put it on there. Ooh, we get to make it contravariant. We'll change our method to async. We will await next.send. And we will create ourselves a message validator. Which will implement our method. And for now, we'll just return completed task. So I want to be able to validate this message. So I created a validator type. I have a message validator. When I have my filter run, if I have a service to validate that message, I want to pull that from the container, and I want to be able to validate that message. So let's save this out. Go ahead and run it. Oops. Okay, ding. So we'll save this out. We're going to run it. Hopefully it works. Never tried it. I mean, I've never tried it. I mean, I've tried it, but I've not tried it like right now. Where's my Swagger UI? So for 61, we're going to execute. I'm going to watch this come up. It's going to run the saga. It's going to send it to the consumer. I didn't write anything out, but it didn't explode, so that's a good thing. I never actually registered a validator, but if the iService provider was not in the payloads, it would have thrown an exception because I didn't try to get it. I actually just said get it and throw an exception if it isn't there. So the validator so it got the service provider. The validator wasn't there though because I didn't register one for that message type. So let's go back and let's actually make this, do our favorite debugging tool, and we'll say validated. I don't have the consume context, so let's do that. Let's give myself the entire T of the world, so I have access to all the things. We'll change the signature. And now we'll say validated 0, and we'll do context.messageID. So now we'll actually see if we actually validated something. And we'll just pass the context. We'll also go back to program, where we're adding the consumer in the consumer definition. Maybe we'll just say services.add transient. Or we could even do add scoped because we're within a scope. iMessage validator. Is it empty trash bin? Message validator, empty trash bin. What did I do wrong? Nothing. Okay, good. All right. So now we actually added a validator for that message type. So when we go out here and run it, We send it a message. It comes up. Should unbind the saga. That would be nice. Right here, we can see validated, and we actually validated that message. So it did go out to the container, it did find the message, the validator, and it called the validator. So that's how you would access container scope within a filter. Some people have asked previously, I think one of the things that gets confusing is they say, well, I wanted to create an instance of my filter for every message call. Yeah, it doesn't really work that way because the filters have to be bound in the pipe when the pipe is created. But I mean, just like we have a consumer factory, I guess theoretically we could make like a filter factory that like plumbs it in line. But yeah, I think this is an acceptable way to do it. It kind of eliminates the abstraction kind of on your own to do it, but it makes it easy enough to plug that in. And I don't think it would be too hard to build a facility around this, but for what it is, it works pretty well. So you can do filters on send and publish. I'm not going to go into that now because we're already in an hour, and I think that's enough. But hopefully this was a good introduction to middleware. I do think that it's probably one of the coolest features of MassTransit. It makes it highly composable. When Drew and I were talking the other day about things that have survived in MassTransit the longest, because the code base is going on 12, 13 years now. I mean, we started it in 2007, and it's 2020. So we're coming up on 12, 13 years of actually having this code up and running. I think we had like a non-version numbered version of MassTransit running on MSMQ back in like 2007, towards the end of 2007, but it was there. The things that have lasted the longest, the first one was the decision to use types for routing. That's one thing that has been in the platform forever. We've always done type-based routing. The pipeline is the thing that's lasted the second longest. Almost every other piece of MassTransit has been rewritten. But those are the two things that have lasted the longest. So I thought that was kind of interesting. Just, in terms of decisions that were really hard to make at first. Because when the pipeline was first built, the TPL wasn't even out yet. Or it had just been released. I don't even know that it had been just released, but we were trying to do a lot of like continuation passing type stuff, and it looked like some of the early Java continuation passing or JavaScript continuation passing before everybody and their brother copied async and await. So it really opened it up, and I mean, it really made it pretty performant as well too. So you're able to build a lot of stuff on it. So hopefully this was great. A little background there. I'm going to take a little break. I will be back on. I'm going to just start working on a piece of the MassTransit pipeline, basically the Amazon SQS dispatcher. I'll probably be back on in 10 minutes or so. I'm just putting it on Twitch. I'm not going to put it on YouTube or anything. It's just sort of if it's interesting. I don't think it is, but someone might want to watch and just see how I work within the MassTransit code base. It's a 70 project solution. But I thought it might be kind of cool to go through some of that and look at some of the new system threading channel stuff that I'm looking at using for dispatching messages within SQS. So I'll be back in a little bit. Thanks for joining, and we'll see you in the next episode.